Today's topic is limitations of distribution law, that is association. The molecule should behave as the same molecule in organic and aqueous phase. If it is associating or dissociating, in that case, this formula is not applied. Further, the formula has to change. What is the change? How, why, when? We try to see this. It was found that molecules usually associate in organic layer. In organic layer, they form association. If you take benzene and water system, okay. If you write benzoic acid like this, yeah, this is benzoic acid. This benzoic acid will form a dimer by forming hydrogen bond in benzene. In benzene, it is going to form dimer by forming hydrogen bond. This is called dimer. Note on this, okay? This is called dimer. If it is forming dimer, the formula will change to C1 by C2. Because I am saying dimer, it indicates where 2 is there. If it is forming N mer, okay, what is N mer? I don't know how many molecules. In that case, you will keep N root. In that case, you need to keep that N root. Okay, so that's what the equation is. Now, how to derive this equation? You already saw. Again, I will derive, and you need to derive here once again. Let's see what we do. I have added X, N molecules of X. Now this X, we have organic layer and aqueous layer. This X molecule will partitionate, it will do two things. X molecule will partitionate, okay, between organic and aqueous layers. Aqueous I am writing only X, not NX. Reason, I don't know how many molecules are doing this. Next, it will form dimer. I am writing it here, indicating how many. See, O2, 2 molecules. O3, 3 molecules. Okay, so represent that we are writing N here. Now we need to derive the equation. I need to get this equation. What is that equation? Distribution totally N root of C1 by C2. I need to get this equation. So how to do that? We need to name the concentrations. So concentration is C2. This is C1 and this is C3. According to distribution law, 2 concentration I need to use C1 by C2. So distribution law says that use a concentration which is distributing, not associating or dissociating, which is distributing. So you need to go for Kd is equal to, who is distributing 2 concentrations? 3 and 2. I need to substitute C1 here. We will see what to do. Next, we have 2 things. One is associating, and next is associating from Xn. Okay, and case 1, case 2. Case 2, Xn is dissociating to form NX. What to consider here? What to consider? Okay. Further, you should know what is distributing. Give importance to distribution. It is distributing after association or after dissociation? It is distributing after association or after dissociation? Why is this confusing so much? Take come here. Come. Okay. I don't know how you will form this. How you form this? What happens? Don't continue. Okay. Listen. Now they are forming association. This is Xn. This is association. Now they will in benzene itself. Go there. This is benzene. Okay. In benzene itself, they will dissociate And assume that this side we have water. Assume me as a phase. Okay, this side benzene, this side water. In benzene, he will be distributed. So give importance to distribution. To give importance to distribution, you need to consider association process or dissociation process. Okay, you need to consider dissociation process. So I need to consider this one. Apply law of mass action to dissociation. What is Xn? C1. What is Nx? C2. Apply law of mass action. What it says? Constant is equal to product by reactant. Constant is equal to product by reactant raised to the power of concentration. So C3. Where is the C3? Yeah. So C3 has Nx. In that case, the power of N. Assume X has C3. It has N there. So N is raised to the power of. Why, what, how? Stoichiometric equation. Go back to +2. Read it and come back. Okay. This is how the stoichiometric equation is. Next. Divided by reactants. C1. C1. See here. If it is 2O2. To write a stoichiometric equation, I will write like this. If it is O2, I will write like this. Nothing else. So here it is associated molecule. So I will write C1. So I need to substitute this C1 here. So what should I do? Let's see. So assume this has equation 1. Assume this has equation 2. Substitute 2 in 1. Wait, still we need to classify this. Okay. So I want to substitute C3 there. So I need to get only C3. So send this side. K and C1 is equal to C3 to the power of N. Send N this side. So C3 is equal to nth root K and nth root C1. Now this is 2. This is 1. Substitute 2 in 1. Okay. Substitute 2 in 1. Substitute. So 1 is KD is equal to C3. What is C3? Nth root K and nth root C1 divided by C2. I want nth root C1 by C2. That's all. So send this constant here. So KD by nth root K is equal to nth root C1 by C2. Constant by constant, some constant. Yesterday some said that cancel it. No, this is different constant. This is different. You can't cancel them. It's all together. If it is same, then you need to cancel. This is the constant for distribution. Sorry. Yeah, distribution constant. And this is the constant for dissociation. Okay. Law of mass action constant. Distribution law constant. Totally different. No one. So together I assume that ratio has one constant. I can assume it as a distribution constant or coefficient C1 by C. This is the derivation for molecule if it is forming dimer. Associating and forming dimer. This is the derivation. Okay. So yesterday we did this. Now you already did an experiment. You already did an experiment. How will you come to know? I have to apply this one. See, we have equations, right? Assume you don't know that benzoic acid is forming dimer. You don't know that benzoic acid is forming dimer. In that case, which equation you are going to apply? And how you will pick that equation? You don't know which one it is forming. How you will pick that equation? What? For that we have methods. Okay. Method 1. I will tell you the method, you nomenclature it. Tell you the method, you nomenclature it. Okay. Method 1 is conduct an experiment in 3 or 4 or 5 different concentrations. Conduct an, don't write, listen. when I am explaining this, okay, don't write. Okay. Conduct an experiment in 3 different concentrations. So if you conduct experiment, you get values. What you get? You get value of C1 and C2. Now, submit this value to individual equation. So equation 1 is square root of C1 by C2. Equation 2 is cube root of C1 by C2. Equation 3 is fourth root of C1 by C2. So all these 3 experiments, you get 3 values. C1 1, 2, 3, C2 1, 2, 3. Or C1 for 0.5, C1 for 1, C1 for 1.5. Now you have to submit this equation to this equation. Now you will get the values. By seeing the value, you will determine that this is what it is. How will you determine? What value you are expecting? Further, again, go back to the definition. Definition says the concentration, if an added solute is unable to saturate the 2 immiscible solvents at constant temperature and equilibrium, the ratio will remain constant. Ratio will remain constant. Now, how will you determine if you get the values? Good. Tell me. Constant. Whatever equation gives you constant value. Let's say I am getting 3 times also I am getting constant. I don't know. See, what is the value of distribution of benzoic acid? I don't know. I am just representing it. It is only for representation purpose. Okay. So I am getting constant value here. This is the way how you find out it is forming dimer, trimer or tetramer. Okay. Now name the equation. Name the method. You are, if I use that word, you will name it. You are submitting this. Submitting means what? Very good. Method of substitution. Substitution method. See, you just named it. Substitution method. Oh, sir, I don't want substitution method. I want a more profile. Another method. Please tell me. Okay. Name this one. Take the equation. Convert this equation into graph. Now, you are going to learn a new skill. If you are being given with any equation, how to convert that equation to graph, representing the graph. What I want is with straight line. Graph should be straight line. What is the straight line equation graph? Sorry, equation for straight line graph. No. Loud. Full equation. Good. Yes. Y is equal to mx plus c. You say A, I say B. I say slope as m. So how it looks? Okay, this is how it looks. Sir, what is this? Listen, you never heard this. What the equation is saying is, if you are traveling from y-axis to x-axis, you will encounter all this. That's all. That's what the equation is saying. So y is equal to, it has m, it has multiplication of m and x, plus it has a slope. Sorry, intercept. This is intercept and this is slope. What is the formula for slope? y2 minus y1 by x2. That is the formula for slope. Why I am saying straight line means, if the slope is like this law is not applicable because m should be constant, only one slope. If it is like this, one slope, another slope. This is what slope means. I don't know what you assume. Slope means this one. How slopey it is? Steep or less? That's what the slope is. If the graph is like this, you can't apply this equation here. You can't apply that equation. So, I want to convert this equation into this equation. The famous mathematical equation which helps you to convert any equation into straight line graph. What is it? Apply Apply. Start with L. Log. See, apply log. We'll see how to convert this. Okay. Log kg is equal to log nth root. Listen. Nth root c can also be written as 1 by n. Okay, I will write like this. Log c1 upon 1 by n minus, because it is log a minus b. Okay, log a, sorry, log a by b is log a minus b. So minus log c2. Log x to the power of m. M log x log c2. Set n this side. Wait. I want to send n this side. First we need to send this side. Because it is plus c. It is minus c. Minus means listen, the slope will be like this. This is what minus slope is. Plus slope will be going up positively. Negative slope will be going down. Remember this. But our slope is positive. Hence I want plus c. 1 plus c. So what I will do? I will send this side. So log tell. Send n this side. N log 8. Multiply n with this 2. Plus. Now nomenclature. Y, X, M, C. 4. Tell me what is y axis? Log C1. What is x axis? What is x axis? Log C2. What is the slope? Then what is the intercept? N log. You should learn this. How to point out the points in graph. See, we just created the graph from nowhere, from scratch. Learn this thing. Okay? Don't back it. You can learn it. Very easy. How I do. Now, conduct the experiment in 5-6 different concentrations. Here we are conducting 3 concentrations. For graph to get a straight line, at least 3 points should be. Further, you need more than 3 points. So, conduct the experiment in 5, 6, 7 concentrations. So, point 1, 1, 1.5, 2, 2.5, 3, 3.5, so on. You need to conduct until you are within the unsaturated range. That is the concentration you can take. Don't go for saturation because your law is not applicable. It is applicable only to dilute solutions. It's applicable to dilute solutions. Okay. Now, after conducting the experiment, I will get C values. Experiment 1, C1, C2. Experiment 2, C1, C2. Experiment 3, C1, C2. So, I will plot 1, 2, 3, 4 values. I try to meet the points. I get the graph. How to find it is dimer or tetra? Whatever the slope value you get. Y2 minus y1 by x2 minus x1. If it is 2, it is dimer. If it is 3, it is trimer. And also I can find the k value, constant value also. Substitute slope value in this equation. Okay, see, here you get some value. Let's say this value is x. Some 10, 20 something. So is equal to 20 or 10. So I know n value. Divided by n will give you log kd. Inverse log will give you. So you can find out constant also from the graph. Okay. So for time being, we will know only number of molecules associated. Nomenclature. Then the method. Graphical method. Method of graphical. Okay. We have substitution method and we have graphical method. Right, quick.